To make a quick sketch of y equals sine x, recall the unit circle and the quadrants that the unit circle marks off. So we begin at 0. When we rotate 90 degrees, we're at pi over 2 radians, so that's where our first quadrant ends. When we rotate 180 degrees, we're at pi radians. That's where our second quadrant ends. Where our third quadrant ends, we're down at 3 pi over 2. And then all the way around is 2 pi radians. So those quadrants mark off the key places on our sine and our cosine graph. So I'm going to mark these on my x and y axis. Those should be easy to remember since those are just the 4 quadrants. Then I'm going to recall that when we defined the trig functions in terms of the unit circle, that the function sine gave us the y coordinate on the unit circle. So that means at 0, that my sine is 0 because that's the y coordinate on this unit circle. So at 0, the sine equals 0. At pi over 2, my sine is 1. At pi, the sine is 0. At 3 pi over 2, the sine is negative 1. And at 2 pi, I'm back at 0. And connecting these points with a smooth curve gives me what the sine graph looks like between 0 and 2 pi. I can do a similar thing to graph cosine. I'm going to mark off my quadrants, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And this time, our cosine function, you use the x-coordinate because the cosine function gives you the x-coordinate in the ordered pair. So at 0, we're up at 1. At pi over 2, we're at 0. At pi, we're at negative 1. At 3 pi over 2, 0. And at 2 pi, we're back at 1. Connecting these with a smooth curve, I get what my cosine function looks like between 0 and 2 pi. So y equals cosine for one period is this graph, and y equals sine x for one period is this graph.